So to help us get introduced into the chapter 14 idea, we've got to spend some time going through the regression that we did back in chapter 3. So throughout this, you may have to pause it and catch up, but here's the data. And the first thing you'll need to do is type this into L1 and L2, the crying data in L1, the IQ data in L2, and then do your 2var stats. If you've forgotten, you can go stat, calc, 2var stats, and you'll get your X bar to be 17.39 and your Y bar to be 117.2368. If you don't have those numbers right, try to figure out where you messed up, because otherwise the rest of the numbers that you do in the whole activity will be wrong. So before we continue and go into question 2, I want to tell you what's going on in this problem. There are some researchers who were trying to find a connection between the amount of crying that an infant does and its subsequent IQ. And their logic was this: babies who cry a lot perhaps do so because they're overly stimulated with the environment. And babies who are stimulated greatly by the environment may have their brains work a lot, developing into a higher IQ. So they wanted to test this theory out, and what they did is they got, I think this is 38 babies. They found 38 babies between 4 days old and 10 days old. They provided a stimulus, measured the amount of crying that the babies did in response to that stimulus, and then 3 years later tested their IQ. And so these numbers, the crying and the IQ, go together. So the baby that cried 10 cries in a 20-second period, and so a cry, they said it was like, and every time they hit one of those peaks, they counted that. So a baby that does more peaks is crying more excitedly, I guess. The way they stimulated these babies is they took a rubber band and they smacked them on the bottom of the foot. And then they measured the amount of crying that they did after that. And they probably gave their mom like a free Chick-fil-A sandwich or something for doing it. I am not making this up. You can read it right there. A snap of a rubber band on the sole of the foot caused the infants to cry. I don't make this stuff up. It's too easy. So that's the data. That's what's going on. And we want to see if there's a relationship between these two things. So we've got the data typed into L1 and L2. Presuming, of course, that this is a random sample of babies. And now number 2, it says draw a rough scatter plot. So somebody help refresh me on how you draw a scatter plot. Go to stat plot and turn it on and do a graph of L1 and L2. The first type. It's helpful that there's nothing in your y equals list and that these other two are turned off. To graph it, you're going to hit zoom 9, exactly, and then you're going to sketch that out. Now, by the idea of rough scatter plot, all they're saying is, we know you're doing this in a classroom setting or a testing environment. The AP people and your coach don't expect you to make an awesome graph in this environment. If I wanted an awesome graph, I'd give you a computer and some software and a printer. But I also expect to be able to get the idea based on what you draw that you've done that. And I'm also going to look for a few other things. So draw you a quick graph of it, and then let's talk about it. So now that you've drawn this, there's a few things that you probably forgot that you shouldn't forget. What do you need to put on your graph? You need to put a title. You need to label your axes. And you need to put a scale on there. So you can either do a scale by hitting, oh, there's auto power save. You can hit trace and figure out bounds to put on there. You really only need to put bounds. You don't need to put, 10, 20, 30, 40, 50, 60, 70. Or you could hit window and see where the bounds are that the calculator's given you. But you need to put some numbers on your graph, a title on your graph, and label your axes. L1 is your X. So your crying variable goes on the horizontal axis, and the vertical axis is your IQ. Now, the other thing that we have to do is talk about it. And it didn't explicitly say to talk about it, but that's something you should do when you look at a graph, is talk about it. So what kind of things are you going to look at when you look at that graph? What do we need to talk about? The strength of it, the form of it. So we've got strength, form, and direction. Good. Strength, form, and direction are what we need to talk about. So let's do it first. What would you say the form is? If you were going to put a function to it, what kind of function would you put? It's not real strong for sure. Maybe a line, but the form is going to be, I mean, the strength is going to be pretty weak. And what do you think about the association or the direction? Positive. So I think we've got a very weak positive linear relationship between crying and IQ. I think there's a weak positive linear relationship between crying and IQ. Now, I heard somebody say that we should cuss it. So let's talk about cussing it for a second. What kind of graphs do you cuss? Coach, I cuss all of them. No. What does the acronym stand for? Center, unusual observations, shape, and spread. So give me an example of a graph that you could cuss. A box plot. Good. What's another graph you could cuss? A histogram. What's the difference between a box plot and a histogram and this graph? Yeah, so we got correlation here. The other one I could talk about means. A histogram or a box plot is a univariate graph. Univariate means one variable. Don't be overwhelmed when you see fancy words, because almost always they're not really all that impressive. Univariate, one variable. This graph, the one of IQ and crying, is called a bivariate graph. So with bivariate graphs, we're going to talk about strength, form, and direction. With univariate graphs, we can cuss it. And that would sort of make sense if you started looking at it and you said, wait a minute, where's the center? Because center is like mean, median, or mode. That's harder to figure out for this graph here. Oh yeah, because that's not what I'm talking about. Now, some of you may want to still talk about unusual observations. I personally don't see an unusual observation. A few students have mentioned that this guy might be unusual. So now number 3 says find the least squared regression line. What are R and R squared and what do they tell you? So let's figure this out. On the calculator, you may recall that to find the LSRL, we press stat, calc, and we use number 8 instead of number 4. So we do linreg of A plus BX. So linreg number 8. And when you do this, if your R and R squared don't show up, what else do you need to do? Turn your diagnostics on. So go down to, it's in the catalog, which is second 0. Go down and turn your diagnostics on. When you do your linreg, you have the option to type this in next to it, but you don't need to type that in. It assumes L1 and L2, whether you've put L1 and L2 in there or not. But I would certainly recommend putting a Y1 on the end of it, which is vars, Y-vars, function, Y1. And what is that going to do? Stores that regression equation as the function, so you don't have to remember all the digits. Like I said, the L1 and L2 is optional, so you could simply write it like that. I press, to get the Y1 again, you press vars, Y-vars, it's a function, and then Y1 or Y whatever you want to stick it into. So now you're going to get the same thing, but if you press Y equals, there's that equation stored into your Y equals, so that when you go back and hit zoom 9, it graphs that equation on the data graph. And in a second, we'll use it as a function to plug a number into it, like f of x, and it's got the function already stored in there. So let's go through each of these 4 things and talk about what they mean. I know the question just said what are R and R squared and what do they tell you, but let's go ahead and talk about all of them. What does A represent? The y-intercept. So what does y-intercept mean in the context of this question? No, not the lowest IQ. Well, it is the lowest IQ grade, but when they're not crying. So when there's 0 cries, you smack the baby on the foot, you got nothing. You predict his IQ to be 91.27. Okay. Now it turns out that is the lowest grade because it's the slope is positive, so it's going up. But technically, it's the score. It's the y value when x is 0, because you're not going to write. You're not having negative cries. I expect it to be 91.27. So B represents the slope, and what does slope mean? Esther? Great, that was said very well. Uh, every time the the crying goes up by one cry per 20 seconds, we expect, or we predict, I think was the word she used, we predict the IQ to go up by 1.5. That's important. Don't say the IQ is going to go up by 1.5. That's what the line would predict. Okay. What does R squared represent? It is the coefficient of determination. Great, you're the only one all day who got that off straight away. And what does it represent? Sort of. Sort of, yes. There was a sentence you had to memorize. It was for this one. Say that again. It did end with the least squared regression line of y on x. This says that 21% of the change in y can be explained by the least squared regression line of y on x. And so what does R mean? R is correlation. Good. And what is it telling me? What does correlation measure? Sort of. More than linear. Great. So it's all of that. It's if it's going up or down and how close the points are to a line. So succinctly, correlation measures the strength and direction of linear relationships. The strength and direction of linear relationships. So if the correlation, now we already looked at the graph, so we already know the answer to this question. But if I look at a correlation of 0.45, then I'm going to say I have a weak positive linear relationship. A weak positive linear relationship between crying and IQ. Now I'm not actually writing this down for you guys, but when it says find the LSRL, you're going to write down that equation, and there's two things you need to remember to do. When you write down the equation, what do you need to remember to do? Put a hat on the y, excellent, because it's a predicted value, that's the dreaded -1. And what's the other thing? So you just wrote y hat equals 91.3 plus 1.49x. You got to tell me what x and y mean. Where x is the number of cries in 20 seconds and y is the IQ. Number 4 says draw a rough residual plot, and what do you think about this plot? Probably think it's really hard, coach. That's not what they mean. How do you make the residual plot? Stat plot. L1 in resid. So second list, go to the one that says resid. So it's L1 for the X list, resid for the Y list. Remember, residuals are like leftovers. So let me show you before I graph this, I guess. Residuals are the differences or the distances between these points in the line. They are these vertical distances. Now, a second ago, you guys were remembering something about the squares of these differences, and so you're getting a little confused with all that. This line is called the least squared regression line because this line is the unique line that makes the squares of these residuals as small as possible. There's one line that minimizes the sum of the squares of the vertical distances. That's the least squared regression line. So now what I'm trying to do, the whole idea of regression is to look at the data and say to yourself, I see a pattern. What kind of pattern did you see? Linear. Great. Let's extract the linear pattern from the data and look at what's left. That's the residual plot. So I'm going to look at what's left when I take out the linear pattern. What am I looking for in this residual plot? A pattern. So do you see a pattern? No. If there was a pattern, what that would tell you is even once you had extracted the linear pattern, there's more pattern left. You didn't get it all. So you should have done something besides linear. Well, here I don't see any pattern left, so it appears that that linear pattern I extracted from the get-go was sufficient. It was an appropriate choice. So you're going to make a quick graph of this. What would you label your horizontal axis as? Well, if you've forgotten, you could hit trace. What did we put on the horizontal axis? L1, which is crying. And what did we put on the horizontal axis? Residual. So that's what you label it as. Now that's not, you could actually put other things on the horizontal axis besides crying. I don't care if you always do crying, but if you're looking at a graph somebody else has made, be very aware of the way they've labeled it. Several times the AP test has given people a graph, and students expected the graph to be a certain way, so they didn't bother to actually read the labels on the graph. And it wasn't the way they expected it to be, which could be deceiving, I suppose, or mischievous by the College Board folks, but that's just the way they went. We do want to hit trace on this and get an idea of the magnitude of the residuals because we've hit zoom 9, so the residuals have exploded to fill up our screen. So when I hit trace, I see this residual right here is -19. Obviously, this one that's over here is the biggest residual, but unless you've hit trace, you don't know if this distance is like, 2 or 2 times 10 to the -5th or 2 times 10 to the 5th. You don't know. So hit trace and get an idea of the magnitude, or again, you could hit window and get the idea. We already know that the line doesn't do a great job because my R and my R squared were kind of crummy. So I expect the points to be kind of spread out, but you still want to get a scale on there to get an idea of how wrong you are. So finally on number 5, it says use your regression equation to make a prediction if there's 24 peaks. So on my home screen, I'm going to go Y1 of 24. Vars, Y vars, function Y1 of 24. That's the prediction. If it doesn't work, then there's a chance you didn't ever stick it into Y1 to begin with. You'll have to go through and plug it into the equation you did back on number 3 the long way. And so that's my prediction at 20 seconds. So that's basically the idea of everything that we did in Chapter 3, and now we can move on. In Part 2, we'll see how this relates in Chapter 14.